Hello, viewers. Welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal, and this is lecture number 2 on boat and stream. So, in this lecture, we are going to solve previous year questions on boat and stream. So, let us begin with the very first question. A man rows from A to B upstream and B to A downstream in 12 hours. So the distance between A and B is also given to us, that is 240 kilometers. The time taken by the man to row 6 kilometers downstream is identical to the time taken by him to row 4 kilometers upstream. Okay. So what is the speed of stream? So we have to find the speed of the stream. So let us begin with the solution. So the speed of upstream is equals to speed in still water minus speed of stream. And also the speed of downstream is equal to speed in still water plus speed of stream. And another formula that is useful is distance equal to speed into time. So let the still water speed be x and the stream's speed be y. So we have assumed that the still water speed is x and the stream speed be y. So here the total time taken from A to B and from B to A is 12 hours. So the total distance from A to B is 240 kilometers, that is given to us. And now, according to the given question, we have speed in downstream equal to x plus y and speed in upstream equal to x minus y. And also the time equal to distance upon speed. So we will have 240 upon x plus y plus 240 upon x minus y equal to 12. Now, simplifying, I will have 1 upon x plus y plus 1 upon x minus y equal to 1 upon 20. And doing the cross multiplication here, this like this, I will have x minus y into x plus y equal to 40x. So this means x minus y is equal to 40x upon x plus y. So this is equation number 1. So I am naming it as 1. Now, it is given that the time taken to cover 6 kilometer downstream is equal to the time taken to cover 4 kilometer upstream. So this information is also given to us in the question. So as time is same, so the time is equal to distance upon speed. So 6 upon x plus y equal to 4 upon x minus y. Okay. So this is the conclusion that we have drawn from the previous statement. So 3 upon 2 is equal to x plus y upon x minus y. And doing the cross multiplication again like this. So it is going to be 3x minus 3y equal to 2x plus 2y, which is x plus x equal to 5y. We have a relation between x and y. Okay, now use this relation and use the equation number 1 to obtain the exact values of y. So now put the value of x equal to 35y in equation 1 and we get 5y minus y equal to 40 into 5y upon 5y plus y, which is equal to 4y equal to 200y upon 6y. So 4y equal to 100 upon 3, which is equal to 25 upon 3 kilometer per hour. So the speed of stream is equal to 25 upon 3 kilometer per hour. So the correct option here is going to be option number D, 25 upon 3 kilometer per hour. Now, moving on to problem number 2. Find the time taken by the boat to travel 80 kilometer with the current if the speed of the boat in still water is 14 kilometer per hour and the speed of the current is 6 kilometer per hour. So speed downstream is equal to speed of boat plus speed of stream. So this is a formula that will be helpful here. Time equal to distance upon speed. This is a very helpful formula we are mostly using each and everywhere. So the downstream speed will be 14 plus 6 equal to 20 kilometer per hour. So let the time taken be t. So I will have 80 kilometer upon 20 equal to t, that is t equal to 4. So the answer is going to be t equal to 4 hours. Therefore, I can say the time taken by the boat to travel 80 kilometer downstream is 4 hours. So the correct option here is option number D, 4 hours. Moving to next problem, problem number 3. The speed of a motorboat in still water and the speed of current of water are in ratio 20:4. So the ratio, the speed of motorboat in still water and speed of current of water are in ratio 20:4. This information is given to us. To go a certain distance along the current, the boat takes 4 hours. Find the time taken by the boat to cover the same distance against the current. Speed of boat along the current is equal to speed of boat in still water plus speed of current of water. The speed of boat against the current is equal to speed of boat in still water minus speed of boat of current of water, and speed equal to distance upon time. So these are the useful formulas that will be used while solving the problem. So let the speed of boat in still water be 20x. Then the speed of water current is 4x. And let the certain distance covered be d. So the speed of boat along stream is 20x plus 4x equal to 24x kilometer per hour. And the time taken is 4 hours. So according to the question, distance equal to speed upon time. And now speed is 24x and time is 4. So distance will be 96x kilometer. So hence the distance traveled is 96x kilometer. So the speed of boat against the stream will be 20x minus 4x equal to 16x kilometer per hour. So now according to the concept, time equal to distance upon speed. So time equal to 96x upon 16x equal to 6 hours. Hence, the required time is 6 hours, which is option number A, 6 hours. Now, moving on to problem number 4. A boat can travel 21 km in 3 hours going upstream. It can travel 55 km in 5 hours going downstream. What is the speed of the stream? So let me first quickly recall the formulas that will be useful in this question. So the first of all, upstream is equal to u minus v kilometer per hour. Downstream will be u plus v kilometer per hour. And here u is speed of the boat in still water and v is the speed of the stream. So let's assume the speed of the boat in still water and the speed of the stream is u and v respectively. So now, a boat can travel 21 km in 3 hours going upstream. That means u minus v equal to 21 upon 3. So u minus v equal to 7 km per hour. So this is equation number 1. Okay. And it can travel 55 km in 5 hours going downstream. So that is u plus v equal to 55 upon 5. So u plus v equal to 11 km per hour. That is equation number 2. So now we have two equations. Subtracting equation 2 to equation 1, we will have u plus v minus u minus v, and it will be 11 minus 7. So 2v equal to 4. Speed of the stream v equal to 2. Therefore, the required answer is 2. The correct answer here is option number D, 2 km per hour. Moving ahead with the problem number 5. Iceland team, while rowing, covered a distance of 20 km downstream in 2 hours, and the same distance upstream is 5 hours. Find the speed of the stream. So the distance equal to speed into time, and this formula will be helpful in this question. So let the speed of the stream be x and the speed of the boat be y. Then for downstream, 20 equal to x plus y times 2. So 20 equal to 2x plus 2y. This is equation number 1 for upstream. And 20 equal to y minus x times 5. So that will be 20 equal to 5y minus 5x. That's equation number 2. So multiplying equation 1 by 5 and equation 2 by 2, subtracting both of them, and I will have x equal to 3. Okay. So therefore, the speed of the stream is 3 kilometer per hour. So option correct here is option number A. Now, moving to problem number 6. The speed of a boat going downstream is 22 km per hour. The speed of the stream is 1 km per hour. How much distance in total will the boat cover going 3 hours downstream and 2 hours upstream? We know upstream speed equal to x minus y and downstream speed equal to x plus y, where x is speed of boat and y is speed of stream. So given that x plus y equal to 22 km per hour and the speed of stream is y equal to 1 km per hour. So x equal to 22 minus 1 equal to 21 km per hour. So the distance equal to speed upon time. So the total distance is going to be 3 times of x plus y plus 2 times of x minus y, that is 5x plus y. So using the above value of x and y, the total distance is going to be 5 times 21 plus 1, which is 106 kilometer. So the correct answer here is option number C, 106 kilometers. A man takes 4 hours and 30 minutes to row a boat a distance of 18 km downstream and 3 hours 30 minutes to row the boat distance of 7 km upstream. Find the speed of the stream. Let's assume that the speed of the boat in still water is a km per hour and the speed of the stream is b km per hour. The distance traveled downstream is 18 km. We know that the time taken to cover this distance downstream is 4 hours and 30 minutes, which is 4.5 hours. So we can write 18 equal to a plus b times of 4.5. So simplifying the equation, we get a plus b equal to 4. The distance traveled upstream is 7 km. We know that the time taken to cover this distance upstream is 3 hours and 30 minutes, which is 3.5 hours. So using the distance formula, we will have 7 equal to a minus b times of 3.5. So simplifying the equation, we get a minus b equal to 2. We now have two equations with two variables. We can solve these equations simultaneously to find the value of a and b. And adding these two equations, we get 2a equal to 6 and a equal to 3. Substituting the value of a in one of the equations, we get 3 minus b equal to 2 and b will be 1. Therefore, the speed of the stream is 1 km per hour. The correct option here is option number D. Moving to problem number 8. Find the speed of a boat in still water. If the boat goes 12 km per hour along the stream and 4 km per hour against the stream. So you have to find the speed of boat in still water. Okay. So let me just quickly recall the formulas that are going to be very useful while solving the problem. So first of all, the downstream speed is given by x plus y km per hour. The upstream speed is given by x minus y km per hour. And let the speed of the boat and stream be x km per hour and y km per hour respectively. So according to the above concept, x plus y is 12 and x minus y is 4. So we have equation 1 and equation 2. Adding these up, you will have 2x equal to 16, that is 8 km per hour. Therefore, the speed of boat in still water is 8 km per hour, which is option number B. A man rows from J to K upstream and back from K to J downstream. In total time of 15 hours, the distance between J and K is 300 km. The time taken by the man to row 9 km downstream is identical to the time taken by him to row 3 km upstream. What is the approximate speed of the boat in still water? So distance upon time equal to speed. So that is the formula that we are going to use. So let us suppose that the speed of boat in still water is b and Speed of stream is S. So a man rose from J to K upstream and back from K to J downstream in a total time of 15 hours. So the distance between J and K is 300 kilometers. So I can write 300 upon B plus C plus 300 upon B minus C equal to 15. And 20 upon B plus C plus 20 upon B minus C is equal to 1. So the time taken by the man to row 9 kilometers downstream is identical to the time taken by him to row 3 kilometers upstream. So 9 upon B plus C is equal to B 3 upon B minus C, and just send this term there. I'll have B plus C upon B minus C equal to 3 upon 1. Applying componendo and dividendo rule, B upon C is going to be T up 2 upon 1. Therefore, the speed of boat in still water is B equal to 2x kilometer per hour. And speed of stream is S equal to x kilometer per hour. So put these value in the equation number 1. I will have 20 upon 2x plus x plus 20 upon 2x minus x equal to 1, which on simplifying will give 20 upon 3x, 20 upon x equal to 1. So 20 plus 60 equal to 3x and x equal to 80 upon 3. Therefore, the speed of boat in still water is b equal to 2x kilometer per hour. So 2 into 80 upon 3, that is 53.33 kilometer per hour. A boat can travel 42 kilometer in 6 hours while going upstream. If the speed of the stream is 2 kilometer per hour, then how much distance will the boat cover in 12 hours while going downstream? While rowing upstream, the upstream speed is a difference between the speed of the boat in still water and the speed of the flow. While rowing downstream, the downstream speed is the addition of the speed of boat in still water and the speed of the flow. So it is distance equal to speed into time. Now, upstream speed equal to 42 upon 6, and that is 7 kilometer per hour. So the speed of the boat in still water is 7 plus 2 equal to 9 kilometer, and downstream speed is equal to 9 plus 2 equal to 11 kilometer per hour. So now the distance covered by the boat in 12 hours is 11 times 12 equal to 132 kilometer. Therefore, the distance covered by the boat in 12 hours is 132 kilometers. Moving ahead with the problem number 11. A boat can travel in still water at 7 km per hour and the speed of stream is 3 km per hour. Find the total time in hours taken by the boat to travel 60 km upstream and remain to the starting point. Let me just highlight some important points in the question first before we move to solution. While rowing upstream, the upstream speed is difference between the speed of the boat in still water and the speed of the flow. While rowing downstream, the downstream speed is the additional speed of the boat in still water and the speed of the flow. So distance is equal to speed into time. So upstream speed equal to 7 minus 3 equal to 4 km per hour. Downstream speed equal to 7 plus 3 equal to 10 km per hour. Now, the total time taken by the boat to travel 90 km upstream and return to the starting point, we have 60 upon 4 plus 60 upon 10 equal to 21 hours. Therefore, the total time taken by the boat to travel 60 km upstream and return to starting point is 21 hours. So the correct option here is option number C. Now, let us move ahead with the problem number 12. A boat can travel 18 km in 3 hours while going upstream and 40 km per hour 40 km in 4 hours while going downstream. What is the speed of the boat in still water? So let me just quickly highlight some points that will be helpful while solving the problem. While rowing upstream, the upstream speed is the difference between the speed of the boat in still water and the speed of the flow. While rowing downstream, the downstream speed is the addition of speed of the boat in still water and speed of the flow. So the third point is distance equal to speed into time. So now let the speed of the boat in still water and the flow of the river be s and r kilometer per hour respectively. Upstream speed equal to s minus r kilometer per hour. Downstream speed equal to s plus r kilometer per hour. So according to the concept, 3 times of s minus r is equal to 18. So the first equation is going to be s minus r equal to 6. And 4 times of s plus r equal to 40. So the second equation will be s plus r equal to 10, which is second equation. So adding these two equation, I will have 2s equal to 16. So s equal to 8. Therefore, the speed of boat in still water is 8 km per hour. That is option number B. Moving ahead with the problem number 13. The speed of boat in still water is 16 km per hour. The time taken by the boat to cover a distance of 18 km upstream is equal to the time taken by the boat to travel 30 km downstream. What is the speed of stream? Let me highlight some key formulas that will be useful here. First of all, speed equal to distance upon time. Upstream equal to u minus v. Downstream equal to u plus v. And here, u equal to speed of the boat and v equal to speed of the stream. Let the speed of stream be x km per hour. According to the question, 18 upon 16 minus x equal to 30 upon 16 plus x. And on simplification, you will have 48 plus 3x equal to 80 minus 5x. So x is here 4. So the speed of the stream is 4 km per hour. So the required answer is option number C, 4 km per hour. Now, if a boat can cover 250 km downstream and 150 km upstream in 5 hours each, then how much distance will wooden object flowing in the river covers in 6 hours? So let me just quickly highlight a few points. While rowing upstream, the upstream speed is difference between the speed of the boat in still water and speed of the flow. And while rowing downstream, the downstream speed is addition of the speed of the boat in still water and speed of the flow. So distance equal to speed into time. The wooden object will flow with the flow of river. So these are the four key points, and let us now move to the solution part. Let the speed of the boat and the stream be 4 b and r kilometer per hour respectively. So downstream speed is b plus r and upstream speed is b minus r. So according to the question, we have two equations. 5 times of b plus r equal to 250 and 5 times of b minus r equal to 150. So you taking the difference of the two equations, we'll have r equal to 10. And now the distance covered by the wooden object flowing the river in 6 hours is 6 into 10 equal to 60 kilometers. So the correct answer here is option number D, 60 kilometers. Moving to problem number 15. A man can row downstream at speed of 15 km per hour and upstream at 11 km per hour. Find his speed in still water and the speed of the current respectively. Give both your answer in kilometer per hour. So these are the formula that will be very helpful while solving the problem. Upstream equal to speed of the object minus speed of the stream. Downstream equal to speed of the object plus speed of the stream. According to the question, upstream is equal to 11 and downstream is equal to 15. So 2 times the speed of the man equal to 26. Speed of the man is 13. So the speed of the stream will be 2. Therefore, the speed in still water and the speed of current is 13 km per hour and 2 km per hour. So the correct option is option number C. Let us now move ahead to question number 16. The speed of a boat in still water is 10 km per hour. The speed of the stream is 2 km per hour. So what is the total distance that the boat will travel if it is rowed 4 hours upstream and 3 hours downstream? So the important formulas that will be useful here is time equal to distance upon speed, speed upstream equal to speed of the object minus speed of the stream, downstream equal to speed of the object plus speed of the stream. So now according to the question, distance covered is equal to 4 times of 10 minus 2 plus 3 times of 10 plus 2. This implies that 4 times 8 plus 3 times 12 equal to 32 plus 36, which is 68 kilometers. So the required answer is 68 kilometers. Let us now see the question number 17. A boat takes 16 minutes and 24 minutes to cover a distance downstream and upstream, respectively. If the speed of the boat in still water is 15 km per hour, find the speed of the stream. So the key points here are while rowing upstream, the upstream speed is difference between the speed of the boat in still water and the speed of the flow. And while rowing downstream, downstream speed is the addition of speed of the boat in still water and speed of the flow. And distance equal to speed into time. Let the distance be d and speed be r kilometer per hour. So the upstream is 15 minus r kilometer per hour, downstream is 15 plus r. So according to the question, d equal to 15 plus r equal to 16 upon 60. So we will have two equations here, d equal to 240 plus 16r upon 60, and second equation is 360 minus 24r upon 60. So from 1 and 2, we will have 240 plus 16r equal to 360 minus 24r. So r is 3. So we will have the speed of stream equal to 3 km per hour. Moving to our last problem. A man rows to a place situated 100 km away and comes back in 10 hours. He can row 12 km downstream or 8 km upstream in the same time. What is the speed of the stream? So let me quickly recall the important formulas that will be helpful. So downstream speed equal to boat speed plus speed of current. Upstream speed equal to boat speed minus speed of current. So distance equal to speed into time. So let boat speed be x and speed of current be y. So as per question, 12 upon x plus y equal to 8 upon x minus y. So we will have, on simplifying, x equal to 5y. Again, putting x equal to 5y, we can say that 100 upon 6y plus 100 upon 4y equal to 10. So y equal to 25 upon 6 kilometer per hour. So correct option here is option number D, 25 upon 6 kilometer per hour. So that would be all for this lecture. So thank you very much.